Chapter 10, Question 9a. Does posting calorie content for menu items affect people's choices in fast food restaurants? According to the results obtained by Ebel, Gamafi, and Kirsch in 2011, the answer is no. The researchers monitored the calorie content of food purchases for children and adolescents in 4 large fast food chains before and after mandatory labeling began in New York City. Although most of the adolescents reported noticing the calorie labels, apparently the labels had no effect on their choices. Data similar to the results obtained show an average of M equals 786 calories per meal with a standard deviation of 85 for N equals 100 children and adolescents before the labeling, compared to an average of M equals 772 calories with a standard deviation of 91 for a similar sample of N equals 100 after the mandatory sampling posting. Use a two-tailed test with an alpha of 0.05 to determine whether the mean number of calories after the posting is significantly different than before calorie content was posted. So this is before, this is after. Step 1, we need to state our hypotheses. So our null is that the mean that the population that this sample comes from, that mean is equal to the mean that this population comes from. Alternatively, we could write it as mu1 minus mu2 equals 0. They're the same. The alternate is that mu1 doesn't equal mu2, or written another way, or mu1 minus mu2 does not equal 0. Step 2, we need to find our critical values. To find our critical values, we need our degrees of freedom. Our degrees of freedom equals N1 plus N2 minus 2. 100 plus 100 minus 2. That is 198. If we go to table B1 or B2, we find that the critical value, the critical T, is plus or minus, because it's two-tailed, it's plus or minus 1.98. Step 3 is that we compute our test statistic. Now, to compute our test statistic, first we have to compute our pooled variance. We've got 2 options here. We were given the standard deviations. The pooled variance formula that we typically use uses sum of squares. So we can either convert the standard deviations into sum of squares and then compute the pooled variance, or we can use another formula for the pooled variance that combines that all in one step, where we have the degrees of freedom 1 times the variance of 1 plus degrees of freedom 2, the variance of 2 divided by the degrees of freedom 1 plus the degrees of freedom 2. And this works because the sum of squares 1 equals the degrees of freedom 1 times the variance. Remember, showing it another way, the variance is equal to the sum of squares. Oh, sorry, that should be a 1 there. Sum of squares divided by the degrees of freedom. So just rearranging it. So we rearrange it, then we plug it right into this formula. That's why this works. The degrees of freedom is n minus 1. So that's 99 times 85 squared. Don't forget to square it there. Plus 99 times 91 squared divided by 99 plus 99. 85 squared, so 99 times 85 squared is 7,225 plus 91, we've got 99 times 8,281, all divided by 198. So this is 715,275 plus 8,819, all divided by 198. Running out of space here. Let's see if I can make it work. So here on top we've got 1,535,094 divided by 198. This is still our pooled variance, not our t. So our pooled variance is 7,753. What we now need to do is we need to plug this value into our estimated standard error formula. Move that up so we still have it. So our estimated standard error, that formula is the square root of the pooled variance divided by n. So that's the square root of 7,753 divided by 100 plus 7,753 divided by 100. $77.53 plus 77.53 square root 155.06. Let's keep 3 digits here, so 12.452. The more digits you keep, the more accurate your calculation will be. 3 is enough for our purposes. So then what we need to do is we need to calculate our t. So our t is equal to m1 minus m2 divided by that estimated standard error. So m1, if you recall, was 786, m2 was 772. And our estimated standard error is 12.452. So we've got 14 divided by 12.452. Which is equal to 1.12. So that's step 3. Now what we need to do is compare step 3 to step 2. So step 4, we're going to compare what we calculated or what we found in step 2 to what we calculated in step 3. easiest to draw it out. Our critical values were plus or minus 1.98. Our calculated value is in here, so it's 1.12, which means it's not, so this is, these two areas here are where we would reject the null. It falls in this middle area. So our decision is that we fail to reject the null. And our interpretation of that is that there is no significant difference before or after calorie labeling.